Okay, everybody. First of all, I want to say thank you for joining us this afternoon for this installment of the ONICON webinar series. Today's webinar is Measure More, Manage Better, Advanced BTU Measurement with the ONICON System-1000. So today's topics that we're going to be covering are the ONICON difference, the System-1000, its features and advantages, improving uncertainty, ONICON BTU meters versus traditional methods. We'll go over some System-1000 applications. We'll cover engineers to end users, benefits of the System-1000. Then we're going to go over some future developments we have in store for the System-1000. And lastly, we're going to end with a Q&A for all of our attendees. Just a reminder, in your GoToWebinar window, there is a question box. Any questions you have, please answer in that box. We have a team behind the scenes that's going to be taking down all those questions and getting them over to us during the Q&A session. So your host for today's webinar is going to be myself, Scott Aboy. I'm the BTU meter product manager here at ONICON.
Buddy, my name is Jacob Biggs, and I'm one of the regional sales managers here at ONICON. Also joining us is our Director of Sales and Marketing, Mike Rivers. He will be joining us after the webinar for questions. Before we dive into the System-1000, let's talk about the ONICON difference. And what that is we believe in engineered solutions configured specifically for your projects that are wet calibrated to a niche traceable standard. Additionally, we have highly trained sales and application engineers to answer your technical support, your install questions, or anything else. Our rule of thumb, if you can't figure it out in 10 minutes or less, call us and we'll help you out. We have unparalleled customer service to help you from the start of your project all the way towards the end. Additionally, we have an entire rep network nationwide that's expanding globally. But most importantly, our leading warranty. We will warranty our product for an entire year. No questions asked, we will warranty it. On top of that, we offer a total 3-year manufacturer warranty.
All right, so let's jump into the System-1000 specifically, and we'll talk about the features and advantages that you have when using a System-1000 in your install. Before we jump into System-1000, what I want to do is just kind of cover the entire ONICON family of products right here. ONICON covers a full line of products for hydronic flow, steam measurement, and natural gas measurement. Highlighted here in blue, you'll see some of the ONICON flow meters that can be used in BTU measurement systems. Highlighted in red, we have some of our BTU energy calculators that are standalone units. Coming up in orange, we have flow meters that have integrated BTU measurement. And lastly, what we're here to talk about today, the System-1000 multi-channel flow and energy measurement system. So we consider the System-1000 to be a total system integration platform. As you can see, any of these ONICON products that we just recently mentioned from the ONICON family of products can be connected to the System-1000, whether it's a clamp-on ultrasonic, insertion electromagnetics or turbine meters, inline electromagnetics, steam meters, gas meters, inline ultrasonics. All of these ONICON products and more can be connected to your building automation system through a System-1000 with information sent to your building automation system over BACnet serial RS-485 and IP. One of the great things about the System-1000 is it's a true dual channel BTU measurement system. So as you can see on the diagram on the right, we consider the System-1000 to be kind of split in half with 2 fully independent channels. Channel A on the left, you can have a full independent BTU measurement of your evaporator side, of your primary chiller. You could have a boiler hooked up to that. And on the right side on channel B, you can have your condenser side, your cooling tower, a secondary chiller if you're staging chillers. You can do heating, hot water, a boiler. It doesn't matter. Both of these channels are fully independent in how they calculate and measure BTUs. You'll have 2 analog or frequency flow inputs, 4 temperature sensor inputs, 2 auxiliary analog inputs, and 4 pulse inputs for the System-1000. And when ordered with match pairs of ONICON's precision current-based temperature sensors, the System-1000 provides industry-leading BTU accuracy. A couple other things I'd like to highlight here are that in the middle there, you can see you can pull in additional meters And those can be domestic water, steam, condensate, electrical meters, gas, air pressure, any of those things. Also, you see there's only a single input power required for the System 1000. And then there's a single connection out to your building automation system. And that includes up to 8 additional analog outs and 8 additional digital outs. We like to say you can get more from your BTU meter when you utilize the System 1000. And again, those key features: total system integration platform, 8 analog or pulse inputs, 8 analog and 8 pulse outputs, BACnet MSTP and IP connectivity, dual channel thermal energy measurement. But we also have advanced functionality, and we'll go over some of this with real-time COP calculations, math input logics, and you can use those to simplify some of your complex installations. The System 1000 also features advanced diagnostics, where on the screen of the device, you can pull up all the raw input and output data, all the way down to what's actually happening out over your network. So you can see from the screen of the device what's going on with your system. Combine that with ONICON support, and you have easy installation and a commissioning procedure. One of our favorite features about the System 1000 is it helps you reduce wall space in a cluttered mechanical room. While we love to see a wall full of a whole bunch of different ONICON devices like these pictures that you've all probably seen in a mechanical room, we know that it presents a whole lot cleaner to have a newer, modern box with a much nicer display and a whole lot more information that you can present to your building owner when the job is done. Some of the other features we like to highlight about the System 1000 is that it comes factory pre-configured for the customer's specification. It's ready to use right out of the box. And we even include a wiring hookup diagram to show you which meters connect to which ports on the board. You can reprogram the System 1000 via the display without having to connect to it with a PC. The System 1000 reduces the number of devices that are connected to your BMS trunk, as well as reducing the number of analog and pulse inputs to that BMS trunk. And again, all of the data that you'll have on your System 1000 is available on the local display, as well as out over your network. Earlier, I mentioned the advanced functionality of the System 1000. Starting off with that, we have coefficient of performance. That is really starting to show up a lot in engineered jobs and engineered solutions in our industry, where people are looking to measure the efficiency of their equipment. The System 1000 can generate that for you. On top of that, it can perform flow addition and flow subtraction to help you out if you're in a situation where you have limited straight run or you need to combine meters to some flow. And lastly, we say the System 1000 can help with complex applications. And here I'm going to show you how. This is an example of an actual project we're currently working on with the System 1000. It's a pretty complex application. If you look at the plan view on the left of the screen, you can see an actual plan view of this mechanical room with 5 chillers, 2 different temperature loops, a high temp chilled water and a low temp chilled water. 2 of the 5 chillers swing with load, whether they go between high temp and low temp. And as you can tell by that plan, it's a really compact mechanical room for that much equipment. So they have limited straight run and wall space. Using the System 1000 and using ONICON products, we were able to help this engineer solve the problems of the complexity in this mechanical room. Since there was no room for flow meters in the risers from the chillers, we placed flow meters in the headers of all the mains, and we're using flow subtraction so that we can take measurements off the main and subtract out before and after chillers, determine how much flow is actually going through the chillers. So if you look at the colors on the diagram, you see the pink oval that's circling 2 flow meters. We're using flow subtraction there to identify the actual flow going through the pink square that is chiller number 3. We've then repeated that down the line in the header with the teal chiller number 4 and the yellow chiller number 5. We're using the flow subtraction features of the System 1000 to help this engineer solve the problem with this complex install. The other thing that we're doing, we're using the dual signal output from the FT3400s, where we're using analog from the FT3400 to talk to one System 1000, and then we're using the frequency output of that FT3400 to talk to a different System 1000 where we're doing the math function. And lastly, we've reduced the wall mounts in this particular mechanical room from 9 traditional energy meters down to, or from 18, traditional energy meters down to 9 System 1000 dual channels.
Thanks, Scott. What we have here is representation of traditional approach for energy metering in hydronic systems. As you can see, the supply and return temperature sensors, the local PLC controller, and the flow meter, which is typically was an ONICON flow meter because it is the gold standard. As we provided these meters for these applications, we realized we were getting a lot of calls back saying, hey, your flow meter is not as accurate as you say it is. What we would do, we would have them bring it back, we would test it, verify it, and it was within the accuracy statement that we said it was. So we decided to look into this problem. And the first area we looked at was the temperature sensors. And we realized the temperature sensors they were using, the Platinum Class A RTDs, weren't very accurate. They had a high margin of error that was affecting the calculation, which inspired us to create our own ONICON temperature sensor. This is a match paired calibrated temperature sensor. How we calibrate this is we calibrate it into a bath specifically for your application. If it's a hot water system, we bath calibrate it in hot water. If it's chill water, we bath calibrate it in chill water. These types of sensors offer very wide range of flexibilities in your install runs and having high accuracy during them. In fact, with their accuracy, we found out that it's better than 0.15 degrees Fahrenheit across a delta T. And when you compare that to traditional RTD sensors that were used previously, in this chart, you can see in yellow on the left, the degrees in Fahrenheit, 32, 41, and 59. And on the right, you can see the potential offset, 0.55, 0.58, with an error of over 5.5%, going up over 6.5% error across a delta T of 10 degrees. And when you compare that to our ONICON match paired semiconductor solid state temperature sensors, you can see in the table the exact same temperatures, but when you look to the right, our potential offset is consistent across the board. And so is our error of accuracy across that 10-degree delta. It remains at 1.5%. And when you graph this out, you can see the difference. And as we know, not every system is perfect. You don't always have a true 10-degree delta T across systems such as a chiller system. Sometimes it's 7, 8. And as you see that delta decrease, your error increases. So let's look at the cost of BTU measurements for error. Chillers have a wide range of efficiency. Let's just assume this is a pretty efficient chiller at 0.75 kilowatts per ton. And you look at the math, the equation to calculate BTUs, you have that specific heat constant of 500, the flow in GPM, and the delta T. And as you can see, that equation is proportional across the board. So you can see the importance of the error wants to be minimal for an accurate calculation. With ONICON, we actually reference the specific heat calculation table for that 500. So we're not using that 500, we're actually using the true value, minimizing error. And when we calculate this, we get the BTUs per hour. And then from there, we convert it to tons and then to kilowatts. And then from kilowatts, we can calculate to dollars. So we can see your cost and error per day, per week, all the way to per year. So let's look at an example. Let's assume that we have a 6-inch pipe. And as you can see, we have a wide range of flow, 360 GPMs up to 720. So let's assume that we're using an average of 500 GPMs in the 6-inch pipe across the day. You can see the difference here in the table between the RTD temperature sensors versus the ONICON temperature sensors. That delta T error, that first thing in yellow there, you can see it's 0.614 compared to our 0.15. And then you see the electricity usage, that chiller that we mentioned earlier, 0.75. Now, when you look at the BTU error, when you do the math behind the temperature sensor and that chiller efficiency, you can see how the RTD temperature sensors are off by more than 153,000 BTUs per hour compared to ours, 37,500. When you look at that annually, you can see the cost difference. It's an over $11,000 error for the RTDs, when it's just over $2,700 in the ONICON. So when you compare the two, it's over $8,300 difference annually, which is typically almost an instant payback, a payback of 1 year or less. So on both sides, the tenant is getting billed for what they're using, and the supplier is billing for what they're actually supplying and what their tenant is using. So when you compare the full error across the board, between the ONICON BTU system, such as the System 1000, versus the traditional approach. You can see the combined error of 1.58 to 1.8% error compared to the traditional amount of 5.3% up to 10% error. Now, as I mentioned earlier, that's in a perfect delta T 10 degrees differential. That error is going to start approaching way closer to 20% if you have a lower delta T. So let's look at all the errors that we're taking on consideration, and this is why we believe you should put it on us to ensure you're getting an accurate BTU calculation. As I mentioned before, it's extremely important to have a temp sensor that's our match paired and bath calibrated per its application. And that sensor accuracy is extremely important, as the flow meter accuracy is. There's all these other factors in computing and signal and processing on the end and outputs and the calculation itself that contributes to that error.
All right, thanks, Jacob. So next we want to look at the System 1000 and some of the applications that you can use one in your install. So first, we're going to start out with the most simple of all, something that if you're in this webinar, then you probably know what a chilled water system is here. So in a chilled water energy system with the System 1000, you'll have a chilled water flow meter. We can add in a makeup domestic water meter. We can add in an electric meter there on the right of the diagram, and we'll have our supply and return temperatures. And so far, we've only used one channel of our System 1000. And out of that, we're going to get our chilled water flow rate and total. We'll get our chiller energy BTU production as a rate and total. And as a side note, if you're someone who's working through an ASHRAE 183 validation, the data that you're getting for that chiller BTU production can help you with your ASHRAE 183 validation. Using the electric meter on the right of the diagram, you can bring in your electric rate, your total electrical consumption. And once we have that in our BTUs, we can do a chiller efficiency calculation for a COP. Now, that's really great if you're trying to verify the efficiency of your equipment or you're looking to maximize your cost savings. We can also then bring in another meter for our makeup water total. And with that, you can monitor for leaks, and you can also use it to monitor your makeup water costs to make sure that they're staying in line with what you budgeted. And of course, you're going to get your supply and return and delta T out to your building management system. So if we look at the other side of the chiller here on the condenser water side, again, we're going to have a condenser water flow meter. We can add a makeup water flow meter as well for your cooling tower system. We can also add a cooling tower blowdown meter. And of course, we'll add our supply and return temperatures. Again, we're still just using one channel of the System 1000. You can mate this with the cooling side on the other channel. But for this channel of the System 1000, we would have our condenser water flow rate and total. We'd have our cooling tower BTU rejection as a rate and total. We can have a blowdown water totalization, and that's great because that allows you to verify that your maintenance schedules are being followed and that your maintenance team is doing what you need them to do. You'll be able to track your makeup water as a flow and a total, and that allows you to monitor the usage to verify your planned consumption. And if you live in a locale where they do sub-metering for cooling towers, it allows you to verify your sub-meter water usage against your utility billing to make sure you're getting that full credit as you planned. So this type of install here will give you your total volume of water consumption from the makeup, the domestic water, and the blowdown. And of course, you get your data of supply, return, and delta T back out of your BMS. Now let's look at a heating hot water system. This is going to be a natural gas-fired system. So you'll have heating hot water flow meter. You'll have an ONICON natural gas flow meter that you can see on the right side of the diagram there. Again, we have a makeup water flow meter and our two temperature sensors. Now your outputs out of the System 1000, again, are going to be heating hot water flow rate and total. Then you'll have your boiler thermal BTU production as a rate and total. Again, this will help you with your ASHRAE 183 validation. With that ONICON natural gas meter, you'll have your natural gas flow rate and total. And coming in Q4 of 2025, you'll be able to do boiler efficiency COP, where we're measuring the BTU generated by your boiler versus the cubic feet of natural gas being taken into the system. So again, you can verify the efficiency of your system and you can maximize your cost savings with that. Again, we'll also be able to do a makeup water total for you there, so you can monitor for leaks and measure your makeup water costs. And again, we'll also have the outputs of supply, return, and delta T. Now this looks a little bit more complicated, so we're getting somewhere here. This is a steam heating hot water system with a heat exchanger. We're going to have a heating hot water flow meter. We'll have a saturated steam flow meter from ONICON on your steam pipe. We can have a pumped condensate flow meter down at the bottom. And of course, we'll have our supply and return temperatures. So in this type of system, we're still operating on just one channel of the System 1000. You'll have outputs to your building monitoring system of heating hot water flow rate in total, saturated steam flow rate in total, the energy exchange rate and total in BTUs. Again, that'll help you with your ASHRAE 183 validation. You'll have a pump steam condensate total, and then you'll have your heat exchanger efficiency starting in Q4 of 2025. We're going to be adding that function as well, where you can do BTUs of the heat exchanger versus the pounds of steam entering it. Again, you'll use that to verify your efficiency and maximize your cost savings. And again, you'll get all your temperature information out of your building monitoring system. As an optional integration here, you can bring a domestic water meter in, and you can have a total water consumption for your entire BMS through the System 1000 on one channel. Lastly, we're going to get into the one application here that actually requires both channels of the System 1000 for this installation. This is what we refer to as a domestic hot water system, excluding the recirculation losses. So what did we do here? We took a domestic hot water supply flow meter going up into the building. We have a domestic hot water recirculation line flow meter returning to the heater room. We'll have supply and recirculation temperatures, and then we'll have a domestic water supply temperature. In this orientation, it uses both channels of the System 1000 and gives you domestic hot water supply flow rate and total. It gives you the flow rate and total of your recirculation line. And then using the energy difference between these two, you get a net hot water BTU energy consumption as a rate and total. So what does this do? It takes the total energy being generated by the heater room and then subtracts the energy being lost through your recirculation line. And so it allows the owner or the tenant to track actual BTU usage of the occupant's hot water usage. The recirculation specific BTU loss rate and total allows the facility owner or the facilities manager to track the losses in BTUs through the recirculation line so they can do improvements to the recirculation system, whether that's flow rate or insulation, so they can reduce those losses that the facility is paying through having a recirc line. Now, as we mentioned before, ASHRAE 183. We know there's a lot of new standards that are coming out right now that require you to meet standards for energy efficiency. The newest one is ASHRAE 183 2024, and that asks that you validate your assumptions. And with all the data from the System 1000, it helps you validate your assumptions. It asks that you monitor actual versus expected loads. Again, all the data in the System 1000 with your BTU performance can actually demonstrate for ASHRAE 183 what those actual loads are versus what you did in your load calcs. And then the continual monitoring that you can do with the System 1000 allows you to detect shifts in thermal behavior over time, and that keeps you also in alignment with ASHRAE 183. A slightly older standard, but equally as important, is ASHRAE 90.1 from 2022, and that says that you have to have compliance with HVAC energy metering provisions. Well, with the System 1000, obviously we're monitoring our energy there. It asks that you have performance-based paths versus via BTU and COP data. Obviously, we've provided both of those as well. The data that you can get out of your System 1000 can help you with the documentation for your energy credits that you can get out of Section 11 of 90.1. And then lastly, 90.1 asks that you do ongoing commissioning and functional testing. With all the information that comes off of a System 1000 regarding your system, it's an easy way to demonstrate that ongoing commissioning and functional testing.
Thanks, Scott. During my last section here, I'm going to talk about the benefits of the System 1000. We all know why building automation systems are essential for building control, comfort, and monitoring for facilities in various buildings. However, most buildings actually are not measuring energy usage or energy efficiency. And that's where the System 1000 comes in. It provides real-time performance data that can be standalone or be integrated into any BAS system. This allows us to deliver more value to our customers by enabling successful energy management. And to have successful energy management, we need to have a clear and robust energy metering or energy monitoring plan so we can detect energy inefficiencies when they're occurring, such as a chiller system, a boiler system, a condenser water system. By installing a System 1000, you can see that data immediately in real time. We can calculate COP, energy efficiency calculations, and energy drifts. Now, if you remember when Scott was talking about his applications, if you remember the boiler diagram, let's assume that you have a high condensing boiler that is near 100% efficient. You want to ensure that boiler is operating at its peak efficiency. If not, it's costing you money. If it drops in efficiency points, you can go out there and service that equipment immediately rather than waiting for the next schedule for it to occur. And you can show the value of that. If it were 3 months out, you can show, hey, we boost this up by 3 percentage points, and you can quantify that to dollars. And let's say it's the flip side. Let's say it's an older boiler and you've been servicing it, but it's dropping in efficiency. Now you can show the reasons and the data-driven decision to replace that boiler because it's dropping in efficiency. You can do a cost analysis to show why it's worth that investment. So by installing it, you can be proactive with your maintenancing and provide data-driven decisions for system upgrades and system replacements. Additionally, it supports greenhouse initiatives. There's a lot of new green initiatives nowadays. As we mentioned, there's the ASHRAE standards, there's LEED and Energy Star, and many more. On top of that, we can measure and validate results. Energy metering provides proof of success for commissioning, system changes and system upgrades, and retrofit commissioning projects. In fact, ASHRAE and the Department of Energy emphasize the importance of energy metering, especially in retrofit commissioning projects that are using measure and verification for energy savings. And these projects, you can save up to 20% annually on your energy bills, which is typically a two-year payback and return on investment. And a huge part of that is BTU monitoring or measuring. In fact, there was a pilot project in Norway that emphasized the importance of energy metering. They had a project that showed you can save up to 10% by monitoring your BTUs, and their goal was only 3% across many campuses. Additionally, you can benchmark true apples to apples comparison. We all know how you benchmark buildings. It's prior months to prior years, utility usage, but that doesn't always create the full picture. With the System 1000, you can bring all your utility meters in. You can see your output BTUs, energy efficiency that's from all your systems. And now you can get a true apples to apples comparison of how your system should be operating all year long. And as we mentioned before, it does support validating, such as ASHRAE 90.1 and 183. But on top of that, also 189.1, which is for energy efficiency and water usage. With the System 1000, we have a flow meter on there. It's calculating total flow and real-time flow, which you can identify unnecessary water usage or water leaks. Studies have shown you can save 10% on your cooling tower and chilled water systems by having successful water monitoring plan. And additionally, you can save up to 30% on domestic water because oftentimes there's a lot of leaks that are very minimal that you just don't see. Now, to summarize, let's look at the main benefits for the big three: your mechanical engineers, your building automation contractors, and your facility managers. For your engineers, it provides highly accurate flow and energy data, confirming that the installation is operating as they intended it to. And for your BAS contractors, it improves control strategies, enables advanced fault detection, while supporting their BAS analytics and dashboards they are providing for their customers. And lastly, but not least, for your facility managers and owners, it tracks energy performance in real time, detects energy inefficiencies early on, supports their budgeting and reporting that justifies maintenance and system upgrades.
All right, great. Thank you, Jacob. So next we're going to cover the future developments for the System 1000. So at ONICON here, we like to continue the growth of our products to help our customers in the field. And so the next generation of the System 1000 that's going to be available in Q4 of 2024, we're going to release it as a 4 fully independent BTU channel system. Along with those 4 independent BTU channels, each channel will have 1 auxiliary flow input per channel, 1 digital pulse input per channel, 2 analog outs per channel, and 2 digital or pulse outs per channel. We also dug into the user interface for the System 1000 based on some feedback we've gotten, and we've installed new keyboard screens that will help you with text and numeric inputs when you're working on the device from the keypad. We've added field editable channel names in case you want to repurpose some of the channels of your System 1000. You'll be able to do it there without the use of a laptop. You'll also be able to field configure the units on the display of your System 1000 for however you want to see them for your mechanical room, and you'll be able to do that through the keypad on the front of the System 1000. Lastly, we've added some new totals. We've added a last 24-hour total, and we'll have a last 30-day totals. And for when you are running those experiments to drive the efficiency of your system, we've added a new resettable total so that you can run an experiment for however long you need to, make your changes, and then rerun that same experiment and have that resettable total without messing with any of your full lifetime totals in the System 1000. As I mentioned earlier, we're also expanding the COP calculations in the System 1000, so you can do them based off of natural gas or steam. We've also decided for our international customers, or just people who like metric, we're going to go ahead and add metric units to the System 1000. And lastly, we're going to be equipping it with Modbus connectivity over serial RS-485 or IP. Once again, all of that is going to be available in the new versions of the System 1000, available in Q4 of 2025. So on behalf of Jacob, I would like to thank you for attending this webinar. We're going to take a minute here off while we go dig into the Q&A session. A reminder, if you have any questions, you can enter them into the question box of your GoToWebinar window. So if you give us just about a minute here, we're going to go look at those questions and we'll be right back with you.
Good job, guys, and thanks again for everyone that joined us today. I've been looking at the questions as everyone was presenting here, and we got a load of good questions. So bear with us as we kind of work on each of us responding to these. But I am going to take the first one. Looks like it's based around our ONICON temperature sensors and how they're calibrated. So I think Jacob did a good job talking about calibrated temperature sensors. And I think the key word there was matched temperature sensors, comparing us to just like standard RTDs, which are typically not, even if they're calibrated, not matched together. So what ONICON does with our solid state temperature sensors is we take the two temperature sensors, and based on the application, it's going to be living in chilled water, hot water, condenser water. We put the two temperature sensors in the same bath, and we compare them to a NIST traceable master sensor. So what's happening there is each one is getting its own slope and offset that we're programming into the BTU calculators. And that what's really key there is that matched sensing, because RTDs can be a 1/4 degree off, a 1/2 degree off, a full degree off. Well, if it's a 1/2 degree off on the supply and a 1/2 degree off on the return, well, if you look at that delta T, that's potentially 1 degree off. Well, 1 degree off in a 10-degree chilled water system, that's 10% error before you start considering the error from the flow meters, the calculations, and so forth, everything that Jacob talked about. So again, we're calibrating them in the same bath. So now, even if it's a 1/4 degree off on the supply, well, it's a 1/4 degree off on the return in the same direction, giving you a really high-end accuracy for that BTU calculation. And of course, everything's coming with then a calibration certificate for the flow meter, the temperature sensors, and the complete BTU system. That was a great question. All right. Let's see. Jacob, do you want to take the next one? Does the System 1000 require field programming?
It does. It comes out of the factory ready to go out of the box. However, if you have system changes that you see in the field, it can be reconfigured very easily. So to answer your question, no, but if it needs to be, you can.
Great. Thank you, Jacob. Another good question. I've always used System 10s. What's the advantage of using the System 1000? Great question. Scott, you want to take that one?
Yeah, sure. I'll go ahead and field that. Well, first of all, thank you for using System 10s before, and I appreciate your interest in the System 1000. We looked hard at the pricing of the System 1000, and first thing we wanted to do is make sure that the System 1000 is priced competitively to two System 10s. Um, we say that when you look at the total installed cost in terms of a lower amount of boxes having to be mounted on the wall, lowering the number of wiring connections you have to do, lowering the number of network connections you have to do. When you sum all of that up, we've priced the System 1000 in a place where it's priced competitive with two System 10s and the installed cost. But again, some of the other benefits we have there are it's going to offer you just one power wiring connection. So it's going to free up space in your mechanical room wall for conduit and things like that. Same with the network connection, single network connection for the System 1000 as opposed to multiple connections for the System 10s. And then also the System 1000 gives you the ability to hook up additional flow meters with all the additional inputs and outputs on the System 1000. You can bring in that additional flow meter per channel, and then you can bring in another couple pulse output type meters. If you're looking to do pulse totalization, you can bring those also in through the System 1000. And it does all that with its standard configuration right here out of the factory, as opposed to the System 10s where you had to choose the right board with the right multiple inputs or multiple outputs or any of that stuff. With the System 1000, it pretty much comes with all of those inputs and outputs as standard features sort. So they're no longer add-ons like they were with the System 10. So a lot of that stuff is benefits that you'll see for using a System 1000.
Thank you, Scott. Someone else, was asking about, what flow meters, like good information on the System 1000, what type of flow meter should I use? And that's kind of a loaded question. I think Scott kind of painted the picture of all the different technologies that we offer. I will say our most popular flow measurement is electromagnetic. Probably most common is our insertion mag meter, like the FT34, the FT3500 series, followed by with our inline mags. But we really take an engineered approach. So typically we like to ask, what's the application, pipe size, new construction or retrofit, pipe material, and so forth, and really provide an engineered solution. So if you have a specific project in mind, encourage you to either contact your local rep or contact our office. Happy to kind of dive into your specific application there.
All right, Mike, it looks like we've got one here that is, are the totalized values kept in memory in case of a power outage? Yeah, it's a great question. The totalized values are kept in a durable EEPROM inside the unit itself in case there is a power outage. That data will be there for you as soon as you power it back on. All the lifetime totals, all of that stuff that you've been accumulating, all that data is going to be there. The only thing that won't be there if you have a power outage, we do take a very small amount of that total and put it into a volatile part of the memory as we're counting and adding to that bucket. So you may lose a little bit of, a couple BTUs here and there, but over the life of a month or a week or a day, it's not a big total that you're going to lose compared to what you're actually going to lose during your power outage. So yes, I would say almost all of the totals are maintained throughout a power outage.
All right, another good question from Craig here. Can a System 1000 be ordered with a matched pair of strap-on temperature sensors? So that's a great question. We do offer clamp-on or strap-on temperature sensors. We've learned that they don't work well in non-metallic pipe. So, PVC, HDPE. So we don't recommend that. We can't offer a solution for metallic pipe. So, you know, carbon steel, stainless steel, copper, and so forth. But we actually have a hot tap thermal well solution. So if you're familiar with our insertion flow meters where you can hot tap in a pressurized system and install an insertion meter. We have the same technique and solution for our thermal wells or our temperature sensors. So I'm going to recommend and push getting a wetted temperature sensor every time possible. It's going to be a much more accurate and a much more responsive temperature reading when it's inside the pipe. Good question. All right, Jacob, can you take this next one? Do the paired temperature sensors come with thermal wells as well, or do we need a field supply the 2 thermal wells?
Great question. Yes, we do provide thermal well kits as an option. However, they do vary in pipe size and pipe material. So we'll need that information to provide accurate thermal wells.
Yeah, and we actually really recommend using our thermal wells. We have a thermal shrink wrap around our temperature sensors. So you actually find that if temperature sensors aren't pushed all the way in a thermal well, there'll be a little air gap. And that air gap is a great insulator for trying to get an actual accurate temperature. So when you're using our thermal wells, temperature sensors go all the way to the thermal well. There's a little locking nut, so you can feel confident the temperature sensors are pushed all the way in, getting a nice snug fit. All right, Scott, you want to take this next one? What is the NEMA rating of the enclosure? Is NEMA 4 available?
Yeah, right now the NEMA rating of the enclosure is NEMA 13. I don't know if it is NEMA 4 certified or not at this time. I know all the NEMA 13 rating, we've done all our own testing here in-house. I just don't think that the System 1000 in its current form can survive the immersion requirements of a NEMA 4 environment.
All right, thanks, Scott. Another good question. This wasn't in regards to our System 1000, but what is the life cycle of the new immersion sensors? I'm assuming that was in regards to our new insertion mag meters. So we've been selling insertion meters since the beginning of ONICON's time. Back in the 80s, we had insertion turbine meters. And even insertion turbine meters with moving parts, we've had meters come back after 20 years. And if it's in a clean, closed loop system with well-treated water, those meters have worked after 20 years and still working great. For the mag meters, we've been selling the insertion mag meters for over 20 years. Kind of same case here, still working great. In the next generation, the FT34 and the FT3500 was released back in 23 and 2024. It's a very similar but improved design of the original F3500. So surely confident that that's going to work for if in a well-maintained system, 20 plus years or the life of the building, we like to say. But that brings up kind of another topic that's worth talking about, and that's, it is good practice to not just install a flow meter and forget about it, but, this is really with any type of calibrated instrument, and that's to validate or recalibrate the flow meter and or temperature sensors after a period of time. And I get that question a lot. How often do we need to recalibrate? And it really depends on what you're doing with the application. We have some customers that are billing tens of thousands of dollars off our meters every month. So we see them recalibrating, actually sending back to ONICON, getting recalibrated meters every year, or sometimes even sooner. Versus, maybe I'm just using this as a monitoring point. Well, in that case, maybe you can get away with every 3 to 5 years, or maybe you can get away with a validation. So I also like to differentiate the terminology of calibration versus validation. For something to be recalibrated, it needs to be compared to or calibrated against a standard that's 4 to 10 times as accurate. So it's really challenging to recalibrate something to that 1% or to that a fraction of percent accuracy in the field. So typically that's where you're removing it, sending it back to ONICON, and getting it recalibrated at our calibration lab. But what you can do in the field is a validation. And that's where you're comparing it to a similar standard. So if it's a flow meter, we have portable clamp-on ultrasonic meters, or you could take it out if it's an insertion meter, put in a second insertion meter. And that's where you're validating it against a similar standard. And so that's also common. Every couple of years, you're validating your flow meters. Hey, this is within a tolerance. I can be happy with the performance or the accuracy from these flow meters. I can validate it's still within calibration. So there's a lot of different ways to kind of approach validation and recalibration. It depends on what type of flow meter you're using, what you're trying to do with the flow meter, and what makes sense for the type of campus that you're trying to manage. So love to have those type of conversations about your particular project or your particular campus. So feel free to reach out.
All right, I think there's one here I'm pretty well equipped to handle. When you use the flow addition and subtraction, does that data track usage and total separate from the channels, or is it always calculated when requested? Specifically with the BACnet interface data points. For example, if you have a bypass with a small pipe and you install a flow meter before and after the bypass, then calculate the amount that is bypassed. Okay, great question. It is a little complex how we handle this flow addition and flow subtraction, and so it is good to fully understand it before you decide whether or not you can utilize it in your system. It is a full real-time data point that you see out of the unit. So what we're doing is we're monitoring both flow meters for flow rate and total continuously. And then we do the math function, whether it's add or subtract, and then you have that data as a flow and total continuously. The one caveat we like to add about this is if it is a channel where you're doing an energy calculation, the energy will be calculated on the result of the mathematical function. So if you're doing flow addition or flow subtraction, that the BTU calculation will be done on the result of that. So it just means when you're planning your system, you have your primary and your secondary flow meters. You have to make sure you place them in the piping system in the right locations so that the result of your math function is the flow that you want to calculate your BTU energy off of. But all three of those flows, the primary, the secondary, and the result of the math function are all available out over the BACnet. And that is available on both channels. So you can do flow addition on one channel, flow subtraction on the other. So now you have basically both channels. You'll have those full three data points coming off of both channels if you're using a math function on both channels at the same time.
Thanks, Scott. Ken Overby actually had a great comment I wanted to mention. He mentioned, don't forget about the back end, fewer BAS modules and fewer switch ports, which is totally true. And that's one of the benefits of the System 1000 over the System 10 as well. So thank you, Ken, for mentioning that.
All right, I think I'll jump on this next one here. Is the connection to BMS, BACnet MSTP, BACnet IP, or Modbus IP selectable? Yes, that is fully selectable from the controller. You do not need to plug into the unit with a laptop or the ONICON diagnostic software. You don't need to do any of that. It's available to access right through the 4 buttons on the controller. You can select MSTP IP, Modbus IP, or Modbus serial as well when it's available. And then in each of those menus, you'll have the ability to enter in all the information you need to know, whether it's your BACnet, your subnet mask, your device instance, all of those things. And it'll also display to you in those fields what the hex address is for the System 1000 that's on your network. So we've gone out of our way to make it fully configurable to you in the field without the need to plug in a laptop, go get a cable, plug it, open it up. Nope. You can walk up to it when it's sitting there on the wall or on your desk if you're doing a pre-configuration, and you can enter all that stuff there. However, if you have some of this information in advance, one of the ONICON advantages is that if you get us that information about how you want your network to be configured, what the device instance it is, what all your net addresses are, we can pre-configure that unit for you coming right out of our factory to help minimize the amount of time that you're spending setting up the device on site, with that hope that you plug it into the wall, drop all the wiring to the correct ports, fire it up and have everything work right away.
All right. I'm not sure. I think we meant to mention this early on. This session was recorded, so it will be available on our website later on, as well as, if you're looking for more information, there's a Find Your Rep on our website to find someone there locally to you, or of course our ONICON office can be contacted at 727 447 6140 or through email sales@onicon.com. Looks like we had another question also regarding, again, NEMA 4 versus NEMA 13. NEMA 13 is rated for indoors, NEMA 4X is for outdoors, kind of oversimplifying it. And asking, can we put it in a metal NEMA 4 housing outdoors? And I think it's worth mentioning first that almost all of our meters are NEMA 4 or have a NEMA 4 option. So it's very common that the flow meters, if they need to be installed outside, then you can bring this System 1000 display unit inside is, I would say, more common than anything. But if you did have an application where it was installed outside, I think you even kind of hinted in your question here that it depends on where it is. It looks like Jeremy, you're the one that asked us, it based in San Francisco. So how you have to vent that, airflow that, or heat that is probably less critical than if you were in a more extreme climate. But I think I'd like to really take that on a case-by-case basis, get our product management team involved, and if you're trying to understand what your exact project or your exact requirements were, and we'd be happy to give you a recommendation on a project-by-project basis there.
Yeah, you see here. Mike, let me go ahead and take this next one here. We got a couple more minutes left.
Let's
says
actually
here,
answer that one direct.
what's that, Mike?
I think we should just answer that one direct.
Yeah.
Probably not suitable associated with that one. Or go ahead if you want to take a quick stab at it.
No, I was going to say it's not currently Measurement Canada approved. If we continue to get requests for it for use for Measurement Canada, it is something we can look at for that. With some of the flexibility to designed into this system, it does make it a little bit more challenging to get a Measurement Canada certified approval because they like to have, to pass the EN 1434 standard that you need for Measurement Canada, they like to have the device a little bit more locked down. And so with all of the things that are adjustable inside of the System 1000, it would make it fairly difficult to achieve that Measurement Canada approval.
Yeah, thanks, Scott. Yeah, I think we are in the process of getting Measurement Canada on some products. It does make the System 1000 more challenging since it has to be certified with a particular product. So in Canada, I would say the System 1000 is more for energy calculations, energy efficiency, monitoring, and wouldn't be, Measurement Canada is really for the billing applications. And then I think this is the last question. Another good question. Are your ROI metrics based on material or actually considering the mechanical install prices? And I will admit we oversimplified that ROI slide. What we were really trying to kind of communicate on that slide was that the ROI of buying a System 1000 BTU meter, it was the dollar value of just our calibrated matched temperature sensors in our BTU calculator versus doing a traditional approach. Because again, I kind of started off the Q&A talking about our calibrated and matched temperature sensors. The inaccuracy gets so out of whack so quickly when you don't have matched temperature sensors. So that's what that ROI comparison was the traditional approach using like RTDs without a high-end matched calibrated temperature sensors versus a System 1000 where it's using those matched sensors. But if you feel like you have a specific need that you like to kind of prove the ROI on your project to add BTU measurement and so forth, that's something that we can help with. Contact your rep, contact your office. Happy to kind of dive in what the project looks like, what the building looks like. I think, it's quite easy today to kind of validate the ROI on finding an accurate measurement. And, if you're going to measure something, you want to measure it accurately. And we can kind of go through that process for your specific application. We just took really generic numbers there, assuming KW, assuming a pipe size, again, just to kind of compare temperature sensors. So that's what that was. But all right, we're coming on to the hour anyways. I appreciate everyone for joining us today. Scott and Jacob, thanks for doing a good job presenting on the new System 1000. We're excited about this new product, especially pairing it up with the other new insertion mag meters and the other new products we're coming out with. If you do have any other questions, again, contact your local rep, contact our sales office, sales@onicon.com, 727-447-6140. And looking forward to hearing from you soon. Thanks again.
Thank you, everybody.
See ya.